Now we will discussing the process of design. Here we'll take a simplified view of the four main phases plus an iteration loop focused on the design of interaction. So what is HCI design? HCI design is considered as a problem-solving process that has components like land usage, target area, resources, cost, and viability. It decides on the requirements of product, similarities to the balanced traits of process of design. First stage is requirements gathering, or what is wanted and establishing what exactly is needed. As a precursor to this, it is usually necessary to find out what is currently happening. For example, how do people currently watch movies? What sort of personal appliances do they currently use? Some methods to gather requirements are interviewing people, videotaping them, looking at the documents and objects that they work with, and observing them directly. The second stage is analysis. After gathering our information or requirements, we order them in some way to bring out key issues and communicate with later stage of design. Third stage is design. This is a central stage when you move from what you want to how to do it. As you go along, our design should be guided by design principles and rules. Next is iteration and prototyping. Humans are complex and we cannot expect to get design right on the first time. We therefore need to evaluate a design to see how well it is working and where there can be improvements. The final stage is implementation and deployment. When we are happy with our design prototype, we need to implement and deploy it. This will involve writing code, perhaps making hardware, writing documents, and manuals.
What are the standard rules of the principles? Principles to support usability. First, learnability. The ease with which new users can begin effective interaction and achieve maximal performance. Flexibility. The multiplicity of ways the user and system exchange information. And robustness. The level of support provided the user in determining successful achievement and assessment of goal-directed behavior. Next, the principle of learnability. First, predictability. Determining effect of future action based on past interaction history. Operation visibility. Next is synthesizability. Assessing the effect of past actions. Immediate versus eventual harness. And we have also familiarity, how prior knowledge applies to new system. And guessability and affordance. Generalizability, extending specific interaction knowledge to new situations. Next is consistency, likeness in input and output behavior arising from similar situations or task objectives. And we have principles of flexibility. Dialogue initiative, freedom from system-imposed constraints on input dialogue. System versus user preemptiveness. Multi-threading, ability of system to support user interaction for more than one task at a time. Concurrent versus interleaving and multimodality. Task migrability, passing responsibility for task execution between user and system. And we have substitutivity, allowing equivalent values of input and output to be substituted for each other. And representation, multiplicity, and equal opportunity. We have also customizability, modifiability of the user interface by user, adaptability or system adaptivity. Next is principle of robustness. Reversibility, ability of user to evaluate the internal state of the system for its perceivable representation. Reusability, defaults, reachability, persistence and operation visibility. Recoverability, ability of user to take corrective action once an error has been recognized. Reachability, forward or backward recovery and commensurate effort. And we have also responsiveness, how the user perceives the rate of communication with the system. Stability, task conformance, degree to which system services support all of the user's tasks, and task completeness and task adequacy. And we have Schneiderman's 8 golden rules. First, strive for consistency. Second, enable frequent users to use shortcuts. Third, offer informative feedback. Fourth, design dialogues to yield closure. 5. Offer error prevention and simple error handling. 6. Permit easy reversal of actions. 7. Support internal locus of control. 8. Reduce short-term memory load. Norman's 7 principles. First, use both knowledge in the world and knowledge in the head. Second, simplify the structure of tasks. Third, make things visible, bridge the gap of execution and evaluation. Fourth, get the mappings right. Fifth, exploit the power of constraints, both natural and artificial. Sixth, design for error. And last, number 7 is, when all else fails, standardize.
Interaction design process. The interaction design (IXD) process is what designers use to create solutions centered on users' needs, aim, and behavior when interacting with products. The IXD process involved 5 stages: discovering that users need and want, analyzing that, designing a potential solution, prototyping it, and implementing and developing it.
Good and bad design. Good design emphasizes the usefulness of a product while disregarding anything that could possibly detract from it. While bad design is one which is not easy to understand, distracting, difficult to use, and short-lived.